Hi, grade 11. So today is lesson 6.4 and 6.5, which is transformations of trigonometric functions. There's a handout on Teams that you should fill in as you watch this video. So the handout looks like this, and it's actually already filled out mostly, but I'm just going to go through this and read it with you and point out a few things, and then we'll do a few examples. So when I have the function sine x or sine theta, when it's transformed, it looks like y equals a sine k theta or x minus d plus c. So a few things to point out. A, k, d, and c here are the same a, k, d, and c we learned about with all the other types of functions. So they do the same things. And the other thing to point out, which again is the same, is this negative sign. So when we look at d, we always have to remember to switch the sign. The transformed function for y equals cos theta is y equals a cos k theta minus d plus c. So same again. Now let's talk about what each of these things do. So a determines the vertical stretch or compression by a factor of a, and if it's negative, it's a reflection over the x-axis. K determines the horizontal stretch or compression, and that's by a factor of 1 over k, just like it's always been with the other functions. And if k is negative, that's a reflection over the y-axis. D determines the horizontal translation. So that's the shift left or right. And if d is greater than 0, or if d is positive, then we move to the right. And if d is less than 0, then we move to the left. But remember to switch the sign from the bracket. C determines the vertical translation. So that's shift up or down. If c is greater than 0 or positive, we go up, and if it's negative, we go down. So from the above information, the following can be determined. A is the amplitude. So we talk about amplitude when we talk about trigonometric functions, so the highs and the lows and halfway between that. K is the number of cycles of the graph compared to the original. So to determine the new period of the function, the transformed function, we do 360 degrees divided by k. Because the period of a sine or cos function is 360 degrees, so we divide by k, and then that is the new period. D is the phase shift, that's called. That's our shift, left or right. That's a phase shift. And the equation of the axis is c, so y equals c. So if c is 3, the equation of the axis is y equals 3. And in order to graph the transformations, you need to do them in this order. So horizontal stretch or compression, so that's K. Horizontal translations, that's D. Then vertical stretch or compression is A. And then reflection is also A. And then the vertical translation, which is C. So keep this handy so that you know which order to do them in. All right, onto the second sheet, or the back. For each of the following examples, state the amplitude, period, phase shift, and equation of the axis. Graph 2 cycles. Use different colors and graph 1 transformation at a time. So, the first function we have is y equals sine 3 theta. So, remember theta is like x, so it's like sine 3x. So, if we go back to the general form for the transformed function, we have y equals a sine bracket k theta minus d plus c. So if we look at this format and then we look at the function we have, we'll notice that the 3 is the k value. So let's state the amplitude. A is 1 here. Then we need to state the period. So remember that we determine the new period by doing 360 divided by k. So that's 360 divided by 3 in this situation. 360 divided by 3 is 120 degrees is our new period. D, or the phase shift, is 0 here, so there's no shift. And C is also 0, so the equation of the axis is y equals 0. That also doesn't change. All right, so we're going to start by graphing the original sine function, and then we'll do the transformation. So for the sine function, sorry, not very straight. We go up to 1 and down to -1. And then we are going to go up by 15. So every other tick is going to be 30. 30, 60, 90, Right, so it's really hard for me to draw neatly on this, so I'll post a picture of my actual drawing after I'm done. So the first thing is the original sine function. So remember that for the sine function, we start at 0, and then our zeros are 180 and 360. We start at 0 and we go up to 1 at 90 degrees, and then we go down to -1 at 270. Okay, so that's the original function. Just label it y equals sine theta. Then we're going to do the transformation. So the only transformation we have here is k, and that's making our new period 120 degrees. So instead of starting at 0 and ending at 0 in 360 degrees, we're now going to do that in 120 degrees. So we have 90, and then 30 more is 120. Do this in light blue. So right there is where we're going to hit 0 again. So halfway between 0 and 120, we need to hit 0. So that would be at 60 right here. Halfway between 0 and 60, we need to hit 1. And halfway between 60 and 120, we need to hit -1. And then we'll continue that trend. And that is 2 cycles of our new function. Those are all the transformations. So we are finished, and we can label this y equals sine 3 theta. So here's the graph that I actually did on paper, just a little neater, so you can see the original function there, and then the red is the transformed function. All right, on to number 2. So number 2 is y equals negative sine 2x plus 3. So we're going to state all the characteristics. So the amplitude is a equals 1 still, but a is negative, so we're going to reflect over the x-axis. Then k is 2, so our new period will be 360 divided by 2, which is 180 degrees is our new period. Our d value is 0, and our c value is 3, which means our equation of the axis is y equals 3. All right, so we're going to start with the k, which is the period. So actually, we're going to start with the original and then the period. So I know that I'm going to be shifting this up 3. So the original sine function goes up to 1, and then I have to shift it up 3. So I'm going to go up to 4 because I know I'm going to need that. So this is this is -1 down here. Making it right there. There. -1, 1, 2, 3, and 4. And then we're going to do the same thing as last time and go up by 15, so every other tick is 30. Okay, so we'll start with the original. In yellow, it's the same as last time because it's a sine function. We start at 0, we go up to 1 at 90, back down to 0 at 180, down to -1 at 270, and back up to 0 at 360. Right, so we'll label that y equals sine x. Sorry, I can't write in the corners. Okay, so next we'll do the k value, which is the period. So the period was 360, but now it's 180. So this whole thing will be horizontally compressed. So I'll end here at 180. Halfway between, I'll also hit 0. Halfway between 0 and 90, I'll hit +1. Halfway between 90 and 180, I'll hit -1. And then we'll just continue this on for 2 cycles. So green is y equals sine 2x. All right, the next thing we'll do is the a value. The a value is 1, so there's no change there, but it's -1, so that's a reflection. So each y value will multiply by -1. So 0 stays 0, 1 goes to -1, 0, 0. -1 goes to +1. Basically, we're just flipping it over. All right, and then the last thing we need to do is the c value, which is the vertical shift. So we're going up 3 units. So we'll take each of these blue dots and move it up 3 units. So from here, 1, 2, 3. 1, 2, 3. 1, 2, 3. All right, and then I'll just connect them. And that's my final function. So that's y equals negative sine 2x plus 3. And the blue was y equals negative sine 2x. All right, I'll post a picture of my handwritten one as well. All right, so here's the one I did on paper, just a little bit tidier. You can see the steps there. All right, on to number 3. So number 3 is y equals 2 cos 2x minus 45 minus 1. So the a value here is 2, that's my amplitude. The k value is 2, so my new period equals 360 divided by 2 is 180 degrees. The d value is 45, that's positive because of the original negative in the original. So that's 45 to the right. And then my c value is -1, so my equation of the axis is y equals -1. So looking at what I need to do, I'll be stretching this by 2, so I'll have to go up to 2 and down to -2. But then I need to shift it down 1, so that means I'll have to go down to -3. So I need to make sure that my scale is big enough for that. Sorry if this is painful to watch when I can't draw straight. So -3, -2, -1, 0, 1, 2. And then, since I have to shift by 45 degrees, I'm going to use every other tick as 45 degrees this time. And I just went up to 450 as well. All right, so I'm going to start with the original cos function. Now the original cos function starts at 1 and then goes down to 90, and then at 180 it's down to -1, back up to 0 at 270, and up to 1 again at 360. Connect those with a smooth curve, and that's y equals cos x. All right, the next thing we do is the k value, so we need to get this to a period of 180. So our whole cycle will be completed by here. So halfway between that, we will hit -1, 0, and 0. And then same, we'll do 2 cycles, so we'll just copy that again. There's 2 cycles. That's y equals cos 2x. The next thing we do is the d value, so we're going to shift 45 degrees to the right. So every point is going to move over 2 lines. And then connect with a smooth curve. So green is y equals cos 2x minus 45. The next thing we do is the a value, which is 2. So each y value gets multiplied by 2. So instead of starting at 1, we're going to start at 2. 0 stays the same. Down to -2. 0 stays the same. Up to +2. Down to -2. 0. Up to +2. And then the last thing we do is the c value. So it's -1. We're moving everything down 1. Oh, this one over here should be at -3. And then try to connect those with a smooth curve. And that is our final function. Y equals 2 cos 2x minus 45 minus 1. And here's a picture of my handwritten one as well, just for a little clearer version. And that's today's lesson, so let me know if you have any questions, and I'll talk to you soon.